Okay, in this video we're going to take the derivative of natural log. So let's go ahead and start. Students will be able to take the derivative of ln, the natural log. Luckily, just like e to the x, we've seen this before in earlier videos. I did that on purpose to kind of lessen the blow when we got to this point. So let's review some properties of natural log. Now, the first one, let me rewrite it for you. Looks like there might be a little typo. This should say ln of 1 is equal to 0. And the reason why is this. If I sketched a graph, just a quick little graph, let me grab another color here. At 1, my ln of x actually crosses 1 on the x-axis, so that means my height here would be 0. So that's why that's true. You're also allowed to separate these. So if you have ln of a times b, that is the same as rewriting it as ln of a plus ln of b. Nice property that logarithms and natural logs have is also you can bring down an exponent. So if you have ln of a to the n power, that can be rewritten as n times ln of a. And then finally, last but not least, if you have ln of a over b, that can be rewritten as ln of a minus ln of b. So keep these properties in mind. They might help you with simplifying. Actually, they will. In terms of differentiation rules, we know the first one, basically, the derivative of ln x is 1 over x. Now, this one we don't know. We've never seen this one before. There's more to that. It's basically the derivative ln of any monomial, binomial, trinomial, so forth, so on, is 1 over that monomial or binomial, trinomial, times the first derivative of it. Okay, and this is a new one, so this is going to be very useful in this video. Alright, let's give it a go. Okay, so derivative of ln of x cubed. So let's go ahead and let's use our second formula. It says this: the derivative of ln of x is equal to 1 over x times x prime. Okay, so I didn't leave myself much room, but that's okay. So basically it says this. This is going to be 1 over x cubed times 3x squared, which can be rewritten as 3x squared over x cubed. Finally can be written as 3 over x. So that's using the formula. We could use chain rule here, and we get the same answer. Okay, so let's grab Mr. Green and let's do part B. So in part B, I'm going to do chain rule. The derivative of, and basically it looks like this. If I'm taking chain rule, it's something within something, and it's the derivative of the whole thing times the derivative of the inside. So that's chain rule for you. Okay, so the function itself is y equals ln of x to the 4th power. So I'm going to take the derivative of the whole thing. Y prime is equal to 4 ln of x to the 3rd times the derivative of the inside makes 1 over x. Done. Not too bad, huh? Okay, let me grab Mr. Blue again. Looks like I have a little bit of quotient rule. If you don't recall what quotient rule's formula looked like, it's f divided by g. And if we take the first derivative, we get the derivative of the top, f prime, times the bottom, minus grouping symbol, derivative of the bottom, times the top, all over the bottom squared. Okay, so let's give it a go. F prime of t is equal to, okay, derivative of the top is 1 over t, times the bottom, which is t squared, minus grouping symbol, derivative of the bottom is 2t, times the top, all over, and this should be a t, the bottom squared. Okay, not too bad. Let's see what else we have here. Okay, it's going to get a little bit more complicated. Don't stress out. Alright, so on this one, what I want to do is I want to use my chain rule because it's something within something. And the book's chain rule is kind of confusing on this one, so let me go ahead and start. Let u equal the inside, ln of t squared. Take the derivative. du is equal to, okay, we're going to use that formula. So the formula says this. This is going to be 1 over t squared times 2t dt. I can clean that up as t or 2t, excuse me, over t squared dt, which is the same thing as saying 2 over t dt. All right. y equals ln of u. Take the derivative. dy is equal to, in this case, 1 over u times du. Okay, we're in good shape. Plug all the junk back in. Let me grab a different color here. So this would be dy is equal to, we said u was ln of t, so this is 1 over ln of t squared, times, we said du is this, which is simplified down to this, so times 2 over t dt, divide dt from both sides, and there you go. It's not pretty, but that's the answer. Alright, let's jump to our another example. Okay, on this one I'm just going to use the formula. Remember, the formula says this: ln of x, if I'm taking the derivative, and x can be a monomial, a binomial, it doesn't really matter. It's 1 over x times the first derivative. So on this one I get y prime is equal to 1 over x cubed plus 1 times 3x squared. Alright, pretty easy using that formula. Okay, so it looks like I'm going to use the formula again. I get 1 over sine x times the derivative, which is going to be cosine x. And if I simplify this, I get cosine x over sine x, which just makes cotangent x. Alright, hopefully I'm not going too fast for you. Okay, on this one, it's a mess. What you want to do is you want to use the properties of natural log to rewrite it and then take the derivative of each piece separately. That'll make it so much simpler. So let me rewrite this. You get ln of x times the quantity x squared plus 1 squared minus ln of the denominator, and I'm going to rewrite this as 2x cubed minus 1 to the 1/2 power. Okay, we're in good shape. I can rewrite the first one again. ln of x plus ln of x squared plus 1 all squared, and then I can bring the exponent down. That makes 1/2 ln of 2x cubed minus 1. We're still in great shape. Okay, so if I bring down the exponent here, I can start taking the derivative. Derivative of ln x is 1 over x plus 2 times, okay, I'm going to use my formula here. I get 1 over x squared plus 1 times the derivative inside, which makes 2x, minus 1/2 times, okay, use the property again, 1 over 2x cubed minus 1 times the first derivative, which makes 6x squared. Okay, it's not pretty and you can definitely clean it up, but I want to make sure I have time to finish the last problem. Okay, so on this one, with natural log problems, don't be afraid when you're taking the derivative. Just simplify it down, use the properties. I can rewrite this as ln of x plus 1 plus, oh, sorry, it's division. Be careful, use your property correctly. So it's going to be minus ln of, and it's going to be x minus 2 to the 1/2 power. I can rewrite it a little further, ln of x plus 1 minus 1/2 ln of x minus 2. Okay, let's use our property, or excuse me, our rule for differentiation. This will just be 1 over x plus 1 times the first derivative, which is 1, minus 1/2, and then the rule again, 1 over x minus 2 times 1, and then basically you can simplify. If you simplify it a little bit more, you get 1 over x plus 1 minus 1 over 2x minus 4, and you'd have to find the least common denominator and then simplify it even further. So let's go back up. Let's see if we hit our learning goal. Students will be able to take the derivative ln. I think you're well on your way. Remember that this rule right here is very, very useful. Saves you lots of time without doing chain rule. Alright, I'll see you on the next video.